Good evening, ma'am. My name is Pratham Gupta, 21 BC 1966. I belong to the D2 slot with Professor Dr. Anita X. So today's my topic of discussion is application of finite automata in search engines. First, what is automata? Automata is the study of abstract machines and the computation problems that can be solved using the machines. This abstract machine which solves the problems is called the automata. The main motivation behind developing the automata theory was to develop methods to describe and analyze the behavior of discrete systems. Now, what does automata consist of? The automata consist of two things, states and transitions. The state is represented by circles and the transition is represented by arrows. Automata is the kind of machine which takes some strings as input, and this input goes through a finite number of states and may enter in the final state. It is the study of machines and automata, as well as the computational problems that can be solved using them. Let's proceed. What are the types of automata? There are four major types of automata. First is the finite state automata, second is the push down, third is the linear bounded automata, and fourth, the final one, is the Turing machine. In this presentation, I will mostly discuss about the finite state automata. There are two major types of finite state automata. One is the deterministic finite automata, second is the non-deterministic finite automata. Next, in the next slide, we will discuss about what is finite automata. What is finite automata? A finite automata is a simple idealized machine which is used to recognize patterns within input taken from the alphabet C. The job of a finite automata is to accept or reject an input depending on whether the pattern defined by the finite automata occurs in the input. Now, what does finite automata consist of? Finite automata consist of five tuples. First, Q, second, sigma, third, delta, fourth, Q naught, fifth is F. Now, what does each one denote? Q denotes the finite set of states. Sigma denotes the finite set of input symbols. Q naught is the initial state, F is the final state, and delta is the transition function. Now, what is deterministic and non-deterministic type of finite automata? In deterministic finite automata, in response to a single input alphabet, the state transits to only one state. In DFA, no null moves are there. But in non-deterministic finite automata, null moves are there. What is non-deterministic finite automata? In response to a single input alphabet, a state may transit one or more than one state. This is non-deterministic finite automata. Let's consider an example of DFA. In this example, we can see that each state is having some input symbol. Like, what does it mean? In this example, we can see that each one is giving a transition of 1 and 0. A, when given a transition of 1, it gives a self loop. When given a transition of 0, it moves to AB. When AB is given an input symbol of 0, it gives a self loop. When is given an input symbol of 1, it proceeds towards AC. When AC is given an input symbol of 1, it proceeds towards A, and when given an input symbol of 0, it proceeds back towards AB. Here AC is the final state. As we can derive from the table, we can see that when A is given an input symbol of 0, it goes towards AB. The same thing is described in the table as I have explained earlier. From this example, we can derive many examples. Small strings like 1001, 001, 01, 11001, 10001. If we combine all them, we can see that it gives 1 star 0 0 star 1 as a regular expression or an example. Next, let's see an example of NFA. In NFA, we can see that each state is not having a transition. Only A is having a transition of 0, 1. B is having a transition of 1, and C doesn't have any transition. From the table, we can derive that when A is given an input symbol of 0, it is giving a transition on A and B. When given an input symbol of 1, it gives a transition on A. When B is given an input symbol of 1, it gives a transition on C. And C doesn't give any transition even if 0 and 1 is taken as an input symbol. Let's proceed towards the search engine. What is a search engine? A search engine is a software program that helps people find the information they are looking for online using keywords or phrases. Search engines are able to return results quickly. even with millions of websites online, by scanning the internet continuously and indexing every page they find. When a user searches an item, the search engine looks at its website titles, contents, and keywords it has indexed and uses algorithms to produce a list of options or sites with the most relevant websites at the top of the list. Companies of SEO. What is SEO? It is search engine optimization. The companies use SEO to help search engines recognize their websites as highly relevant to the particular searches. Popular search engines are the Google, Yahoo, which we use in everyday life. The information may be mix of links to web pages, images, videos, articles, research papers, and other type of files. Now, what are the applications of finite automata in the search engine? There are many different types of applications of finite automata in search engines. Among them, the most important one is the string searching with DFA based algorithm. What is DFA? We studied earlier. DFA is the deterministic finite automata. Now, what is the application? Idea of this application or approach is to build finite automata to scan text T for finding all occurrences of pattern P. This approach examines each character of text exactly once to find the pattern. The two main searching algorithms are the brute force algorithm and the Rapin-Karp algorithm. Why is string searching important? With the World Wide Web expanding with databases from diverse fields, it has become a growing concern for people to find an efficient searching algorithm for the task. The power of the algorithm over another is its time complexity and efficiency of operation. A lot of algorithms have been designed for string searching, but some have high time complexity or some efficiency is less. Some of the fast string searching algorithms were developed based on the DFA, deterministic finite automata. The DFA approach is used to overcome problem of backtracking which is faced by the brute force approach, thereby improving the time complexity, speed and efficiency of the search based on the results obtained. What is brute force algorithm? The brute force matching algorithm compares the pattern symbol by symbol in each of the text. Starting at the beginning of the text string, we compare the symbols of pattern one after another where with the corresponding symbols in the text until a mismatch is found or the complete pattern is exhausted. If the pattern is exhausted, we claim to have found a match at the beginning of the text. If a mismatch of symbol is detected before the pattern is exhausted, then the pattern does not occur at the beginning of the text. Then matching is started all over again at the next symbol in the text and continue the same procedure. What is the procedure of brute force algorithm? In short, if you want, this is the algorithm of the brute force approach. If the first symbol of the pattern is same as the first symbol of the text, increment pattern and text to the next symbol of pattern and next symbol of the text respectively and check again whether they match or not. As long as successive increment of pattern matches successive increment of text until the next end of the pattern is reached and announce match success. If the first symbol of pattern is not same as the first symbol of text, shift pattern down to the right by one position so that first symbol of pattern is aligned with the next symbol of text and check whether they match again. As long as subsequent shifts of pattern does not match successive increment of text until text is exhausted and announce match failure. Finite automata algorithm for string searching. A finite automata search algorithm follows certain steps like constructing a DFA for the pattern performing the search. Each character in the text is examined just in the sequential order. When searching is done, a state transition table for the automata is created to represent the state transition function. Now, how DFA searching algorithm is better than the brute force approach? The brute force approach requires the input text string to the backtracked whenever there is an unsuccessful match with a symbol in the pattern. This problem of backtracking raises the computational time of the algorithm. Backtracking is the phenomena where the text string jumps to the next position whenever a mismatch occurs at the current position. Whenever the pattern is shifted to the right as a result of mismatch, it can otherwise be said that it is the text that has been shifted to the left, so the next text symbol can be compared with the pattern. Evidently, the computational complexity of the algorithm is O(m)(n) is the worst case. This is the quadratic order time implying that the brute force algorithm is slow. On construction of the state diagram of the finite automata of a pattern, we can scan the text or to search for the pattern by comparing each next text symbol only once, not occurring any backtrack when there is a mismatch. Hence, we can find all the occurrences of the pattern in the text of length n in O of n time. This is the significant difference of DFA string searching algorithm compared to the brute force approach. I would like to thank Dr. Anita X for giving me this golden opportunity for golden opportunity to implement my theory knowledge in a practical field. Thank you.